Hi, ladies and gentlemen. This is Mr. Gagnon. We're going to take a look at kinematics. Okay, in terms of the formulas. So we remember that kinematics is the study of motion. Okay, and what we're going to look at is the first kinematics #1 formula. And I'm going to do a couple of examples with you guys to show you how to solve for the different variables. As we remember, the variables are things such as time, initial velocity, final velocity, acceleration, displacement, and distance. So let's look at the first formula and break it apart a little bit. Okay, the first formula tells us that the final velocity is the initial velocity plus the acceleration times the time. Okay, so I'm going to give you a situation where we're actually going to solve for a final velocity of an object given the fact that we know an initial velocity, an acceleration, and a time. Okay, let's pretend that you're driving along in your car, okay, and you're already moving at a velocity, an initial velocity of 15 meters a second. Okay, so you're driving along, and we want to know if this car accelerates positively. That means it's going to increase its velocity. So if it's increasing its velocity, the acceleration is going to be positive. So my question is, like, what is the final velocity? That's my question. Given an initial velocity of 15 meters a second, okay, and then an acceleration of 2 meters per second squared for 10 seconds. Okay, so for a 10-second time burst, this car is going to go from 15 meters per second to some higher velocity because it's accelerating.
Good morning.
Because it's accelerating positively. Okay, so it's very important to realize that a positive acceleration will increase the final velocity. So let's just do this out. Look, I've solved my steps here. Okay, my first step was to draw a picture. Second step and third steps were to identify the knowns and unknowns. My third step is to choose a formula. So I have done that. Vf is v naught, or initial velocity, plus at. And then the next step is to plug in what you've got. So Vf is v naught, or initial velocity. And don't stress the units all that much when you're doing the problem. Just know that velocity units are going to be meters per second. Plus a times t. Okay, so we're going to solve for velocity final, 15 meters a second, plus 2 times 10 is 20. And it actually turns out that it's meters per second. So the velocity final would be 35 meters per second in the positive direction. Okay, so that's just taking this formula for face value and solving for final velocity. Now, I'm going to give you situations where I give you a final velocity, acceleration, and time, and you're going to have to find out what the initial velocity was. Okay, let's do that next. So we're still looking at kinematics formula #1. Vf is initial velocity plus acceleration times time. Okay, in this case, I'm going to ask for the solution for initial velocity. Okay, so we have a situation where I'm going to give you the fact that I know that my car has a final velocity of 20 meters a second. Okay, it had accelerated from some initial velocity. Okay, it accelerated from some initial velocity for some time. So what I'm looking for is initial velocity. Okay, and I've got a final velocity of 20. Okay, I'm going to give you an acceleration of 2 meters a second squared. Okay, and all this means is that it's increasing its velocity by 2 meters per second every second. Okay, and then a time of 5 seconds. So the question would be, what is the initial velocity of the car given this other information? And look, I followed the process. I drew a picture. I've got the unknown, I've got the knowns, and now I'm going to choose a formula. Now I've got this formula here. VF is V naught plus AT. Now with this, okay, I can also say that I can plug in what I know here. So I'm just gonna do it this way to show you how I get it done. Okay, so VF is 20 meters a second equals V naught plus A, which is 2, and then the T is 5 seconds. Okay, so if I go like this, I've got 20 meters per second equals our unknown plus, what's 2 times 5? Well, it's 10 meters per second. Okay, so to get the VO by itself, I'm going to subtract the 10 and subtract the 10. Okay, so on this side of the equation, what I have left is 10 meters per second equals initial velocity, or initial velocity is 10 meters per second. So I know that this car started out at 10 meters per second. Okay? Now, I didn't change this formula around to get that answer, and I'm finding it that it's actually pretty easy to do it that way. Now, I also gave you a formula sheet. Looks kind of like this, which all I did was I took all those 3 formulas and I changed them to what you need to find. So like, let's say I needed to find initial velocity. I would go in this section right here. I don't know if you can see that on the screen. But initial velocity has 3 renditions. So when you have like displacement, acceleration, and time, then you can use this one. When you have velocity, final, acceleration, and time, you use this one. You could get away with using these formulas that I gave you for this. Basically, I rearranged the formula there. Okay? So let's take a look at the next rendition. So this would be considered like example 2 for that formula. Okay, still looking at our formula, VF is V naught plus AT. We solved for VF, we solved for VO, or initial velocity. Now we're going to solve for acceleration and time. Okay, so since I said you can solve for acceleration and time, you can look at your sheet and say, well, hey, if I want to find for acceleration, I got time, initial velocity, and final velocity. So when you have time, initial velocity, and final velocity, you can use this rendition of the formula that's already solved out for you. You can see that. Okay, acceleration is VF minus VO over T. All that is this solved for A. Okay, so you have a choice here. You can either use this sheet, which already has it solved out for you, or you can just plug and chug here. Okay, in solving for A, again, we've got our picture. Okay, the car has an initial velocity. It ends up moving along. It's accelerating. It's got a final velocity. Let's put a negative acceleration in there to cause the thing to slow down. So let's say it starts out at 20 meters a second. Let's say it ends at 2 meters a second. Okay, so it's decelerating, or negatively accelerating from 20 to 2. And let's see what else we can put in here. So we're solving for A. Okay, what's the acceleration here? So let's take a look at it. Let's just put A here. Acceleration is question mark. VF is 2. V naught, or V initial, is 20. Okay. Time. Let's say this all happens in 4 seconds. Okay. So I'm giving you the time, I'm giving you the initial velocity, I'm giving you the final velocity. You just need to calculate the acceleration and use your negative signs because it's going to come out negative. I know it is because it's slowing down. All right, so let's plug and chug. VF, we choose a formula. Okay, so you can either use this one or you can use the one that I gave you on the card that says A is VF minus VO over T. Now let's just stick with our original formula here. VF is 2, V naught is 20, plus A times 4 seconds. Okay, and here's where you start having to use your math skills a little bit. 20, now I got to get rid of the 20, minus 20 on both sides. On this side I got negative 18. 20 cancels, plus A, 4. A times 4. Okay. To get rid of the, actually equals. To get rid of the 4 attached to that, divide by 4. Okay, and our answer is going to come out to be 18, or negative 18. Negative 4.5 meters per second equals the acceleration. Okay, so this thing's slowing down. I came up with a negative number for acceleration, and that makes sense because I went from 20 to 2. Okay, so that's rendition number 2. Okay, still looking at the same one. VF is V naught plus AT. Now you guessed it, we're going to solve for time. Okay, so I'm going to give you a situation here. Again, we'll use a car. We tend to use cars. We're going to give it an initial velocity of 1 meters a second. It's going to increase its velocity to a VF of 30 meters per second. So here it is. It's going 30 now, pretty quick. It has, so we've got an initial velocity, we've got a final velocity. I'm going to give it an acceleration. So the acceleration is 9 meters a second squared. So every second it increases its velocity by 9 meters per second. It's pretty quick acceleration. Initial velocity is 1. Final velocity was 30. And then we're going to see how long it takes to do this. Okay, this is kind of like the 0 to 60 race in the car to see how long it takes for that to do that. So the time, well, we're going to choose a formula. Now, here's the deal now. Okay, so what I've done was, again, on this sheet here, okay, I've located and I've solved for time for you. So time, VF minus VO over A, you can take a direct route like that. Or you can realize, hey, Mr. Gagnon got this formula from somewhere, and it's VO plus AT. I just solved for T for you. It doesn't hurt to solve either way. Now, if you want to keep it down to a minimum of 3 formulas, then you don't have to deal with all these, which is kind of enticing for some people. I personally like to keep it 3 formulas instead of I don't know, we have 9 or 10 maybe 12 formulas over there. I'm solving for time, so I'm just going to plug and chug here. 30 equals 1 plus A, which is 9, times T. Now, guys, if you have something attached that you can get rid of, you got to get rid of this one first. Minus 1 meters per second. Minus 1 meters per second. So on this side, I got 29 equals 9 t. I'll keep the unit off there for a second for you. 9t. So getting t by itself, okay, I divide by 9. T's now by itself. I got 29 divided by 9. And the time it takes for all this to happen is 3.2 seconds. Okay, so what I've done for you is I've solved for each rendition of the problem, and it's going to give you the tools that you need to be able to solve for these problems. Now, I just wanted to show you that if I went and I solved for t for this formula here, and you may find this more enticing, but I have VF, VO, and A, VF, VO, and A, and I solve for t. Let's see what kind of how quick we can get that answer using this second way. So time is VF minus VO over A. So if we say this, VF is 30 meters a second minus VO is 1 meters a second over 9 meters a second squared. This may be more enticing for you. Okay, you may actually start to look at this and say, well, this is pretty useful. It's up to you guys. Okay, you can either take the 3 kinematics formulas, just 3 of them, and use them how this way, or take, you've got lots of them here that I've changed around for you. So in this one, it's 29 over 9, which ends up being 3.2 seconds. Okay, same answer. Okay, same answer. It's just a personal choice. If you want to stick it to 3 formulas, and keep it simple, go for it. But if you want to look at this sheet and say, hey, he already solved for every rendition of everything here, so why not use this? That's fine too.